Hello, today we are going to take you through the process of properly using the scientific method. And for all of you who are now terrified because of the word scientific method, this video is meant to help take you through the scientific method one step at a time to make it as simple and painless as possible. Let's get started. First up, we're going to give you some background on the scientific method. The scientific method is a process used to explore observations and find answers to questions. We use the scientific method in order to search for a cause and effect relationship. It is very important to define every process of the experiment you are doing in a simple and easy way so that it can be replicated with no problems or conflicts. The scientific method starts when you ask a question about something you have observed. The question that we will be asking today is, what are the effects copper sulfate has on plant development? When you choose a topic, we want you to keep in mind that this should be something that matters to you. For example, farming is an extremely important industry on the Palouse, so plant and soil health are topics of top priority. Remember, you must ask a question that you can measure. Numbers are the easiest way to do this. After you ask a question, you must do background research on your topic. Instead of just shooting into the dark and trying to construct a plan from scratch, you should always do research on the topic beforehand. Search the internet, go to the library, and read scientific journals to find information on your topic, so that when you are designing your experiment and conducting it, you won't repeat other people's mistakes. For this topic, we chose to talk to soil scientists, read various journals, and search the internet to get a good baseline idea for what we are going to do. Make sure to record all of the resources you used and write everything down. These will be crucial later on. Now that you have formed a question and done your research, it is time to take that information and turn it into a hypothesis. A hypothesis, by definition, is a proposition or educated guess made on a topic based on limited evidence, which is used as a starting point for an investigation. In order to formulate a hypothesis, you will need to remember three little words: if, then, and because. Our hypothesis for this experiment is: if we test radish seeds with different concentrations of copper sulfate, then we will see the effect copper sulfate levels have on radish's germination rate, because we will test them in a controlled environment and observe the results. Again, make sure you are writing all of this down and recording it. Now it is time for us to move to the bench. With a hypothesis formed, we must test it now by doing an experiment. This experiment will test if your hypothesis is being supported or not. It is crucial that this experiment is a valid test. You keep the experiment valid by only changing one variable at a time and keeping all the other conditions the same. You also should repeat your experiment to make sure your results each time correlate with one another, and so you know if you made a mistake. Once you have tested your experiment, go back and make sure your procedure is working. If it is, then you can move on to the next step. If it isn't, you'll need to troubleshoot and figure out what is going wrong. Go back and check your steps and execution to make sure that they are accurate. Again, you must write down everything you are doing, all the supplies you are using, and what you observed. If you don't, then other scientists won't be able to replicate your experiment properly. For our experiment, we are preparing 4 different dilutions of copper sulfate and then placing 5 milliliters of each one onto a petri dish with filter paper, and then placing radish seeds on them. Our control will be a petri dish of sterile water and radish seeds. We will store them in a dark area and record their germination rates. Once your experiment is complete, it is time for you to collect your data and analyze it to see if it lines up with your hypothesis or not. You will look at all the information you have collected and have been recording to complete this step. Keep in mind that there is a chance that your hypothesis won't be supported. In instances like that, you will take the information you collected and use it to form a new hypothesis and a new experiment. This will start the process all over again. Even if your hypothesis was supported, many times scientists will redo their experiment by testing their hypothesis again, just in a different way. In our case, the data showed us that copper sulfate in fact does have an effect on the germination and growth rates of radishes. We will be repeating this experiment again though, using more dilutions of copper sulfate to see at what point it becomes toxic. Finally, you are going to take all the information you have collected, everything you have recorded, and all the background information you used, everything, and communicate these results and findings with others. In many cases, this will be in the form of a scientific paper. Regardless of if your hypothesis was supported or not, you will need to report those findings. This step is why you must record and write down everything as it happens. Don't forget to review these important steps in the scientific method while designing your own experiments in the future.